I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, posting brilliant questions and excellent suggestions. Now, based on your suggestions, we have been regularly posting videos. Here is one on logarithms. We are going to explore the laws and apply them to expand logarithmic expressions. The question here is, expand logarithms. Use laws of logarithms to expand expressions as sum, difference, and or constant multiple of logarithms. Assume all variables are positive. Assume all variables are positive is a very important statement here. So wherever you see x, y, or a, b, c, they are all positive. Now it is important since you know the logarithmic functions are defined where the argument is greater than 0. Questions are before you. You can pause the video, answer them one by one, and then look into my suggestions. In case you want to learn from me, you can send an email on the address given. Our students do extremely well since they understand the basic concepts and they have the confidence of solving the most difficult questions also.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So now, let's first look at the laws of logarithms. We also say properties of logarithms. Log of 1 is always 0, as you know. Log to the base b of b is 1. Log to the base b of b to the power of x is x. And when you write in exponential form, b to the power of log to the base b of x, it is just x. Since this part is inverse of one another. Here is what we are going to explore more in this particular video, the two properties when we have product of expressions. In that case, they can be written as sum, right? So log to the base b of xw will be log to the base b of x plus log to the base b of w. Now here it is very important to understand that all these variables which is we're talking about are greater than 0. Otherwise, we would have been writing absolute value of x and w, right? So let me write down here in general. If I say log to the base b of xw, that is equal to log to the base b of absolute value of x plus log to the base b of absolute value of w. You get the idea. Since we know that the log functions are defined for values greater than 0. Now, why this is very critical? Can you explain why? Why did I use absolute value? Well, it is important to note that if you have, let me write down, x times w as defined as greater than 0, then there is a possibility that both are negative. You get the idea. So if both are negative, their product is going to be positive, right? And that is where this form is very helpful. So I hope you got the key. That's a very important point to understand as we move forward. Perfect. So let's take up these questions one by one and go through their solutions. The very first one here is log to the base 2 of x y over 8. So you could write this as log to the base 2 of the numerator xy subtract log to the base 2 of the denominator 8. Now, log to the base 2 of xy can further be expanded, and we can write this as log to the base 2 of x plus log to the base 2 of y minus. Now, what is log to the base 2 of 8? Can you tell me that? Well, this is equal to 3. Now, how do we get it? So, we could write this as 8 as 2q, right? So, I could write 8 as 2q. So, now I'll write down my final answer, which is log to the base 2 of x plus log to the base 2 of y minus 3, right? Using the properties of logarithms. So that is how we get our solution. So you should really focus on this component, right? How did we write 8 as 3? Perfect. Let's move on to the next question, which is, let me copy the question first, which is log of, when we don't write anything, in that case the base is 100, correct? No, 10. So the base is 10 and we have log of 100 b squared over cube root of c. So when you expand it, you could write directly also log 100 plus log b squared minus log of cube root of c. Perfect. Now, what is log 100? Log 100 could be written as 10 to the power of 2, right? So I could write this as log 10 to the power of 2 plus log b squared using the properties 2 times log of b minus. Now, cube root of c. What does that mean? Okay, let's write down. When we have cube root of c, it means c to the power of 1 over 3. You get the idea. So therefore, I could write this as 1/3 log of c. Makes sense, right? So that is one thing. But you have to continue. It is still not done. You see, log to the base 10 of 10 square will be what? Will be 2. So finally, we get here 2 plus 2 log b minus 1 over 3 log c. Make sense? That is how we are going to write its answer. So I hope by now everything is absolutely clear. Feel free to write your comments, and if you have questions, don't hesitate to ask them. In case you want to learn from me, you can always send an email on the address given, or you can contact us on our website. Let's move on and take the next set of questions. Well, here is question 3. Now it becomes slightly more tricky as we move along. We have log to the base 3 of 27 square root of y divided by square root of 1 plus c. How are we going to do this? Well, it seems simple. We could write directly this as log to the base 3 of numerator, which is 27, plus log to the base 3 of square root of y, right? So everything in the numerator comes with plus sign. Everything in the denominator comes with negative sign. So base remains same of 1 plus c. Makes sense? So that is how you could write. And now 27 can be simplified, since you know 27 is what? Well, 27 is equal to 3 cube, right? And since the base is 3, we'll get 3 as our result on this. So we'll use this property and then continue simplifying it. So log to the base 3 of 3 cube, right, plus, now that is half, right? So let me this time write like y to the power of half minus log 3 of 1 plus z to the power of half. And now I'll use the property log to the base 3. 3 of 3 is just number 3. And here we get half of log to the base 3 of y minus half of log to the base 3 of 1 plus z. You see that? That is how we are going to expand this. Is it clear to you? Perfect. Now that was a very good question. Now let's move on to question number 4. Question number 4 utilizes the properties of what we just learned. But here there is a twist. Can you pause the video and answer it for now? Let me rewrite this question as log to the base 3 of what? So we are writing it like this. We have x cubed in the numerator, y to the power of 5 in the denominator, and everything is to the power of half. Now how will you write this? See, now I think it is very clear. So you will write this as half times, right? Half times log of all this. You get the idea. X cubed over y to the power of 5. And then half is outside. You see that? Half is outside, and inside we get log x cubed minus log of y to the power of 5. Right? And so the final result will be half, and everything in the bracket, 3 log, well, to the base 3, of course. So let me add base here, base 3. Okay, perfect. Of 3x cubed, right, minus 5 log of base 3 y. So that becomes your final answer. So everything as shown here, you see that half, it comes outside the bracket. Perfect. So these were a few examples based on logarithms with different bases. Now we're changing the base to e. So you know log to the base e of x is basically equals to ln x, right? So when you see natural log, this is called natural log. Perfect. So all of the properties are similar. The only thing is, just as you write log with base 10, when the base is e, we write ln, the natural log. Okay, so can you take your time to answer this question? This can be written as ln, right, e cube plus everything in the numerator comes with positive sign, right, x to the power of 4 minus ln 25. Clear? Now here, ln e cube is what? 3 times ln e plus 4 times ln x minus ln 25. Now ln 25 is a constant. Okay. Now what is ln e? Ln e is 1, and therefore we are left with the constant 3 plus 4 ln x minus ln 25. You see that? That is how you could write your expression. If you want, you can rearrange it. Well, you could rearrange and write 4 ln x minus ln 25 plus 3, whatever. Either way, it is correct. Here is the last question for you. Take this as your test question. So once again, we are using natural log here with the square root. So remember, the square root will go outside, correct? So I'd like you to explore this and then write down your answer. Perfect. So take your time to answer this question. It is slightly tricky. Okay, at the end, here is my solution. I will write this as ln just as I did earlier. So we'll write down the inside terms, which are e to the power of x, x to the power of 4, plus 1e, and everything to the power of half. So that means half comes outside, and then we have something like this, the whole bracket, right? And then ln what? E to the power of x, right, plus ln x to the power of 4 minus ln 1 plus e, right? Okay, and that gives you half. Ln e to the power of x is just x, right? And plus ln x to the power of 4 is 4 times ln x minus ln 1 plus e. And that becomes our solution. So with that, we come to an end of our exercise in which we took up 6 questions. I hope their solutions are absolutely clear. Perfect. We applied these laws of logarithms and then got all the solutions one by one. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.